Hello and welcome to Training Neural Networks. It's ER Complete. 3 minutes to explain what means training neural networks, and 3 minutes to explain what means ER Complete. Okay, so let me start with what is a neural network. And as a first approximation, a neural network can be seen as a black box. You put in something like images, and you get something out, which is like some information, like this is a woman, this is a man, or this is a little child. So let's try to unpack that box. So the first step you need to understand is that instead of an image, what the neural network gets is actually a string of 0 and 1s, because we all know that's how computer works. And then the whole neural network is made up of these so-called little neurons. And each of these neurons gets a string of 0 and 1s, does something with it, and then sends it along to the next neuron. So all these neurons form a network. Input layer sending to the next layer, which then send something as an output. Let's see what one neuron is doing. Given basically is like a voting. It gets some input from some people, that could be either input or some other neurons, and it makes a vote. And it says, okay, or in an election, everyone gives a vote, and you say 0 or 1, and then I say whether I agree or not, depending on that vote. And specifically, the neuron is giving different weights to different people. So it could say, this guy here is very important, and this other guy I find negligible. And these weights can be trained, as I will explain later. And that's basically what a neural network is doing. It just does these votes, does this computation, and sends it forward. So now how to train these? Very simple. You look at some weights that you have, you try to adjust them slightly, and then if you're better, then you update the weights accordingly. So you always try to see if small modifications can give some improvement, and a neural network makes an improvement if it's doing the correct job on the data for which I know the solution. Okay, now let's come to the second part of the talk, which is what is this ER completeness? Before I can explain ETR completeness or ER completeness, I have to explain what is an algorithmic problem. In an algorithmic problem, we have an input and an output. An example could be that we want to have the shortest route from Groningen to Eindhoven, so we have a map of the Netherlands, we have the start and end point, and then the output would be the shortest path. Once we know what are algorithmic problems, all these algorithmic problems we put into different levels of difficulty. And then we say, oh, these problems are equally difficult, so we put them into the same group. And these groups seem to be ordered. So there is the group called P, which we think is easy, NP, which we think is difficult. And then there is this new group, maybe known for kind of 10 years, which is called ETR or ER. And it's even more difficult than NP. And our results says training neural networks belongs to that group. Okay, so what is this? So this ER or ETR stands for existential theory of the reals. It's just a group of different algorithmic problems which are all equally difficult. And one of them now is training neural networks. To give you an idea of the flavor of these types of problems, look at this algorithmic problem here. We have given some boxes, some unit squares, and we want to find the smallest square container. You can find two properties here. The first is that these squares can be moved continuously. That's one thing you typically see. And the second thing that you see is there's some non-linearity. So you see here that these boxes can rotate. To give you a flavor of how difficult it is, for this instance here, we do not know if it's optimal. So humanity does not know. So it's not just algorithmically difficult to solve. It's just we often just cannot solve it at all. This existential theory of the reals, it gives a good explanation or a partial explanation for two important questions. One is, why are neural networks so successful? And one answer could be, well, they're a tool that can solve this really tough problem, so that they seem to be very powerful. Second thing, the second question that this ER completeness gives a partial answer to is, why do we use this very stupid methods that I explained at the beginning? Well, maybe because this problem is so hard that More sophisticated methods just seem not to be applicable. Okay, that was it. Thank you for your attention.